Electrolysis. Electrolysis is a chemical change caused by passing an electric current through a compound which is either molten or in solution. Electrolyte. An electrolyte is a substance which undergoes electrolysis. Electrolytes have to contain ions which are capable of movement. The current is carried in the electrolyte by the movement of the ions. For example, molten sodium chloride. Sodium chloride solution, it can be dilute or concentrated, dilute sulfuric acid, and so on. From dilute sodium chloride, we get 4 ions. Similarly, from concentrated sodium chloride, we get 4 ions, but the concentration of chloride and hydroxide ions will be different. Non-electrolyte. Solid ionic compounds do not conduct electricity. The positive and negative ions are held close together in a lattice and cannot move freely. The ions are unable to release or receive electron at an electrode. Electrodes. The positive electrode is called anode and the negative electrode is cathode. Because the positive ions are attracted to the negative rod cathode, they are known as cations. The negative ions are attracted to the anode, are known as anions. The mechanism of electrolysis. Anion loses electron and the electrons move through the wire to the cathode. The cation gains electron from the cathode. The ease of discharge of cations. The list of cations are given. The ease of discharge increases. If you have calcium ion and hydrogen ions, from here hydrogen ion will be discharged. Hydrogen is less reactive. If you have sodium and hydrogen ions, hydrogen ion will be discharged. But if you have copper and hydrogen ion, copper ion will be discharged because copper is less reactive than hydrogen. Ease of discharge of negative ions. If the solution is dilute, the concentration of OS minus ion will be more. It will be discharged. If the solution is concentrated, chloride ion will be discharged. Some examples of electrolysis. The first example, electrolysis of molten sodium chloride. Here the electrodes are made of graphite. Only 2 ions are present in the electrolyte, sodium ion and the chloride ion. Sodium ion is positive, it moves towards the cathode and gives sodium metal. Chloride ion is negative, it moves towards the anode and gives chlorine gas. So the products are chlorine gas and sodium metal. Example 2. Electrolysis of dilute potassium chloride solution using graphite electrode. The electrolyte is dilute potassium chloride. The ions are chloride ion, potassium ion, OS minus ion and hydrogen ion. 2 negative ions are present, chloride ion and OS minus ion. The solution is dilute, the concentration of OS minus is greater. So it will be discharged and it gives oxygen gas. This is oxidation reaction. Hydrogen ion and potassium ion. Hydrogen ion discharges easily. It gives hydrogen gas. This is reduction reaction. Electrolysis of concentrated potassium chloride. In this case, the concentration of chloride ion is more, so it will be discharged. So the final products are hydrogen gas and chlorine gas. Number 4. Electrolysis of dilute sodium chloride solution. The ions are sodium ion, hydrogen ion, chloride ion and OS minus ion. From the 2 cations, hydrogen ion will be discharged easily. From the 2 anions, OS minus and chloride, OS minus has the greater concentration since it is dilute. So it discharges and gives oxygen gas. So finally, sodium chloride will be concentrated. Electrolysis of water. We know pure water is non-electrolyte. Few drops sulfuric acid added to water, the water becomes ionized. So water plus sulfuric acid, the ions are hydrogen ion, only 1 positive ion. It gives hydrogen gas. At the cathode, this is reduction. 2 negative ions are present, OS minus and sulfate. Sulfate is heavier, it won't discharge easily. But hydroxide ion discharges easily. It gives oxygen gas. So the products are oxygen gas and hydrogen gas. And finally sulfuric acid will be concentrated. The overall reaction from water, we are getting hydrogen gas and oxygen gas. Electrolysis of dilute sulfuric acid. It's just like similar electrolysis of water, the same types of product, but the heading is different only. The overall reaction I want to discuss, the two equations first I am writing. Then we have to make the electron transferring equal. We are multiplying the second equation by 2. Then we are adding, we get the ions. From here, we are getting water, 2 moles water. We are getting 1 mole oxygen and 2 moles hydrogen. Volume of hydrogen will be double than volume of oxygen. One exercise you have to practice. There are some electrolytes and anode cathode is given. Here the anode and cathode both are made of graphite. You have to complete the ions. What are the ions in the electrolyte and the product at the anode and cathode. Try to complete this exercise. Then you compare with my answer. If you have any problem here, you can write in the comment of this video. Application of electrolysis: metal purification, electroplating, metal extraction. The first one, copper metal purification. Impure copper at the anode, pure copper at the cathode. That is the metal which we want to make it pure, we have to use in the anode. Electrolyte is copper sulfate, the anode corrodes. That is oxidation. So copper ions are coming from the anode. And cathode becomes thick. Copper ions deposit there. The impurities go down as sludge. This way we can make a metal pure. Electroplating, this is important use of electrolysis. A spoon is made of iron. We want to make it more valuable. We have to make the coating on it by silver. So we use spoon as a cathode and silver metal at the anode. The electrolyte is the solution of silver nitrate. The reaction at the anode, silver metal corrodes, so we are getting silver ion. This is oxidation. And the silver ion is deposited to the cathode. The coating is made of silver. The extraction of aluminium. The ore of aluminium is bauxite. It contains many impurities. We have to wash it and clean it. We get alumina, the melting point 2050. If you don't know the ore is the naturally occurring material having large amount of impurities. Since the melting point of alumina is very high, to save energy, we have to add cryolite. The melting point reduced to 950. And the anode and cathode made of graphite. So the reactions at the anode, oxide ion moves towards anode and oxygen gas is produced. At this temperature, anode reacts with oxygen and make carbon dioxide. And only the positive ion, aluminium ion, is present there. It moves towards cathode and gives aluminium, molten aluminium. This aluminium is collected and used for many purposes. A simple electric cell. This cell, we can develop electrical energy from chemical energy. So these similar metals are connected here. The electrolyte is dilute sulfuric acid. The voltmeter connected between the two metals. So the voltage is developed. It depends on the reactivity of the two metals. The difference is greater, you will get more voltage. One practice here, if you understood the previous example, you can do it. You can complete the table. For this one, if you need any help, you can write in the comment of this video. For this chapter or for this topic, if you have any specific question, you can write in the comment below. I think you will get the correct answer. From this video, if you have learned anything, please subscribe the channel and share with your friends. Thank you for watching this video.